Take any integer you want, raise it to the 5th power. Now subtract the number you started with. I promise you, the answer is divisible by 30 every single time. I can prove it. We can test some examples first. For example, n equals to 2. Then 2 to the power of 5 minus 2 equals to 32 minus 2 equals to 30. N equals to 4. We'll have 4 to the power of 5 minus 4 equals to 1024 minus 4, which equals to 1020, which is 30 times 34. And then you can test a negative number. For example, n equals to negative 3. Well, negative 3 to the power of 5 minus negative 3 is equal to negative 240, which is negative 30, or 30 times negative 8. So we're going to start to prove this by factoring n to the power of 5 minus n. And n to the power of 5 minus n equals to n times n to the power of 4 minus 1, which will equal to n times n squared minus 1 times n squared plus 1, which will equal to n times n minus 1 times n plus 1 times n squared plus 1. Now, 30 equals to 2 times 3 times 5. We can prove divisibility by each prime separately. We're going to look at the first 3 factors. Note that these are 3 consecutive integers. So that will mean that 6, because in 3 consecutive integers, one of them must be a multiple of 2 and the other must be a multiple of 3. So 6 is a factor of n minus 1 times n plus 1. And since n minus 1 times n plus 1 divides n to the power of 5 minus n, we get 6 is factor of n to the power of 5 minus n. Now, how do we prove the more complex portion? We want to find out if n to the power of 5 minus n has a factor of 5. This is where Fermat's little theorem comes in. Fermat's little theorem states that if a prime p is not a factor of a number a, then we can get a to the power of p minus 1 is congruent to 1 mod p. For the prime p equals to 5, this says if p is not a factor of n, then n to the power of 4 is congruent to 1 mod 5. And we can multiply both sides by n. N to the power of 5 is congruent to n mod 5. Which would mean that 5 is a factor of n to the power of 5 minus n. Combine these and then we can get that, well, first of all, what if 5 is divisible by n? Then 5 is divisible by n to the power of 5. I mean, 5 divides into the power of 5 trivially, so 5 divides into the power of 5 minus n in that case too. So once you have that proved, we can have, since 6 and 5 are both factor of n to the power of 5 minus n, we can have 30 is a factor of n to the power of 5 minus n for all integers n. So that is how you prove this problem.